Okay, on the previous video we looked at the 45-45-90 triangle. There's really just two relationships there. You know, your legs are congruent to each other, and then there's a square root of 2 relationship between the legs and the hypotenuse. So if you're going from the leg to the hypotenuse, you're multiplying by the square root of 2, and if you're going from the hypotenuse to the leg, you're dividing by the square root of 2. So make sure you understand you're not doubling it. You're not multiplying by 2 or dividing by 2. It's the square root of 2 that is the factor you're using. So now we're going to look at a different kind of triangle, and we're going to look at this animation with a patty paper exploration, but we're not actually going to do the patty paper. We're just going to watch it. So we are going to start off with an equilateral triangle. Remember, that means all the sides are congruent and all the angles are congruent. So all the angles would be 60 degrees. We are going to fold that triangle in half. So we created this segment here. Remember that segment, since this is equilateral, you're coming from that vertex of an equilateral triangle. It is an altitude, it's a perpendicular bisector, it's an angle bisector, it's a median. And so we know that these angles created at vertex, or at point D, are 90 degrees in each one of these smaller triangles. That would leave what degrees for these up at C? Well, if you look at the small triangle CAD, you have a 60, you have a 90, that adds to 150, so that leaves 30 for the small angle ACD up here. Both of these small angles are 30 degrees. They have to add up to be the 60 degrees that we had in the equilateral triangle. So they are just showing you, again, that we folded that in half. And so this is the triangle we're focusing on. This is another one of our special right triangles. It's called the 30-60-90 triangle for obvious reasons. So there are only two special right triangles, the 45-45-90 that we looked at in the first video, and the 30-60-90, which we are looking at now. So if we make the hypotenuse of the 30-60-90 a length of 2, there's one side here that we should know very easily, and it's because, remember, this was folded in half and it was an equilateral triangle. So AD, remember, is half of that side of that equilateral triangle that we started with. So if this length is 2, AD has to be 1. So then we could use the Pythagorean theorem to find the other leg of that triangle. So here they're showing replacing the AD with 1 and using the Pythagorean theorem with the unknown side being B. We're going to replace A with our 1, so that's 1 squared, which is just 1. And then replacing the C with 2, so that is 2 squared, which of course is 4. So when you subtract the 1 from both sides, you're going to get B squared equals 3. We know to solve for B, we're going to have to take the square root of both sides, so B is simply the square root of 3. So this is going to be our reference triangle to help us solve 30-60-90 triangle problems. So it's important to see the 2-to-1 relationship between the hypotenuse and the short leg. The hypotenuse is just double whatever the short leg is. So if the short leg was 3, then the hypotenuse would be 6. If the hypotenuse was 8, the short leg would have to be 4. They have the 2-to-1 relationship. The problem is a lot of students want the 2-to-1 relationship to be with the legs, but that is not so. It's the short leg and the hypotenuse. So the relationship between the short leg and the long leg is a square root of 3 relationship. If you're going from the short leg to the long leg, you're multiplying by the square root of 3. If you're going from the long leg to the short leg, you're dividing by the square root of 3. So just like on the 45-45-90, anytime you're going to something bigger, you're multiplying, and going something smaller, you're dividing. But the 45-45-90, remember, had the square root of 2 relationship, and on the 30-60-90, we have the square root of 3 relationship that we're going to be looking at. So let's look at question 9 in your notes. It says Carlos has to stabilize another tree but does not have room to move out 5 feet from the base. He decides to use 2 wires, one on each side of the tree, each at an angle of 60 degrees with the ground, as you can see here, 3 feet from the base, as you can see labeled here. How high up the tree should he attach the wires? So we're trying to find this length right here. So we really don't care about the hypotenuse of that 30, 60, 90 triangle, but just know the short leg and the hypotenuse have that 2-to-1 relationship. So the hypotenuse would be 6 feet, since the short leg of the 30, 60, 90 is 3 feet. What we want is the long leg. So remember, from the short leg to the long leg, you're multiplying by the square root of 3. So on our notes right here, you should have labeled on number 8 that this is a 1 and this is a square root of 3. And so all we're doing here is multiplying 3 by the square root of 3. And so how high should it be up on the tree? 3 square roots of 3 feet. You just multiply the short leg by the square root of 3. Let's go to our examples here, and I'll just work these on the actual notes. So we're using that reference triangle. The special thing about special right triangles is you only have to know one side of the triangle and you can solve for the other 2. Whereas with the Pythagorean theorem, you have to have 2 sides given to you. So that's why they're called special right triangles. So always pay attention to which side you're given. Here we're given the short leg. So that's the easiest one to be given because we can find the hypotenuse and the long leg from the short leg. Remember, to go from the short leg to the hypotenuse, I'm going to multiply by 2. Remember, this is half of the side of the equilateral triangle we started with. So we have to multiply it by 2 to get the side of that equilateral triangle we started with. To go from the short leg to the long leg, again, going from something shorter to something longer, you're multiplying, but this time we're multiplying by the square root of 3. So we would get 10 square roots of 3 for the long leg. On the next triangle, the 10 represents the long leg. We do not have a relationship that takes us from the long leg to the hypotenuse. So you're going to have to get your short leg first and then use it to find the hypotenuse. So when we were given the short leg, we multiplied by the square root of 3 to get the long leg. We're going to do the reverse of that to go from long leg to short leg. Remember, longer to shorter, you're going to divide. So we are dividing by the square root of 3. So just like we did with the 45, 45, 90, we can't leave a radical in the denominator. We're going to have to do what's called rationalizing it. So we're going to multiply the numerator and the denominator by the square root of 3. So now we have 10 square roots of 3 in the numerator. The square root of 3 times the square root of 3 is the square root of 9, which is simply 3. So we no longer have a radical in the denominator. Now, these numbers outside, if they could simplify, then you would do so. But 10 is not evenly divisible by 3, so we cannot simplify that. That is my short leg, 10 square roots of 3 over 3. So just like we did over here, going from the short leg to the hypotenuse, you just double it. You multiply by 2. But when you take 10 square roots of 3 over 3 and multiply by 2, just understand that 2 is the same thing as 2 over 1. So you don't double the number in the denominator. You also cannot multiply that 2 by the number inside the radical. So the only number affected by the multiplying by 2 is the 10 that's outside in the numerator. So this becomes 20 square roots of 3 over 3. All right, so in question 11, we're just getting some more practice. It's a mixture of your 2 different types of perfect or special right triangles. So we have 2 of them that are 45, 45, 90. Now this one doesn't have angles marked, but it does have the legs marked as being congruent. So remember, we know that means these base angles are congruent, and since that angle is 90 degrees, that means these have to be 45. So this is the 45, 45, 90 triangle. This one has a 90 and a 60, which means this one has to be 30. This one has a 90 and a 30, which means this one has to be 60. And this one has a 90 and a 45, which means this one has to be 45. So we have 2 45, 45, 90s and 2 30, 60, 90s that we're looking at. So on part A, we're given the leg. And so remember, that means the other leg is also the same length. So this would also be 36, but that was not asked for. We're trying to find the value of c. So to go from something shorter to something longer, you're always going to multiply. And in the 45, 45, 90, we're multiplying by the square root of 2. Not 2, the square root of 2. So 36 times the square root of 2 is simply 36 square roots of 2. No units were given. On the 30, 60, 90, we're given the side across from the 30-degree angle. So remember, that's called the short leg. The one across from the 60 is called the long leg. And the one across from the right angle is the hypotenuse. So we're given the short leg. So the easiest one to find is the hypotenuse, because that's that 2 to 1 relationship. So going from the short leg to the hypotenuse, you multiply by 2. So 6 times 2 gives me 12 for y. We're also going from something shorter to something longer when we go from the short leg to the long leg. So we are also multiplying, but remember this time it's the square root of 3 that we're multiplying by. So 6 times the square root of 3 would give x as 6 square roots of 3. On part C here, it's a 30, 60, 90. We're given the side across from the 60, and that's the long leg. So remember that you can't go from long leg to hypotenuse. You've got to go to the short leg first. This is not the 2 to 1 relationship. Remember, that's between the short leg and the hypotenuse. We're going from the long leg to the short leg, so we know we're going to have to divide, and we're dividing by the square root of 3. So we're going to have to rationalize that denominator. 12 divided by the square root of 3. I'm going to multiply the numerator and the denominator by the square root of 3. So I would get 12 times the square root of 3 over the square root of 9, which is simply 3. And I can simplify that. 12 divided by 3 is 4. So 4 square roots of 3 is our Q value. Now to go to the hypotenuse, remember we just multiply by 2. So when we take 4 square roots of 3 and multiply by 2, remember you cannot multiply the number inside the radical by the 2. This would also have to be under a radical for those to multiply. The 2 only affects the number outside, which is the 4. So P is 8 square roots of 2. Just 3, not 4. Not 2. 8 square roots of 3. So 2 times 4 square roots of 3, the 2 multiplies by the 4 and becomes an 8. All right, another 45, 45, 90. This time we're given the side across from the right angle, which is the hypotenuse. So to get the leg length, we're going from something longer to something shorter. So we're dividing. And remember, on the 45, 45, 90, it's a square root of 2 relationship that we're looking at. So we're dividing by the square root of 2. So we're going to take 20 and divide by the square root of 2. Rationalize it by multiplying the numerator and denominator by the square root of 2. So we get 20 square roots of 2 over the square root of 4. 2 times 2 is 4. And the square root of 4 is simply 2. We can simplify the numbers that are outside. 20 divided by 2 is 10. So 10 square roots of 2 is B. And since this is an isosceles right triangle, A and B are congruent. So A is also 10 square roots of 2. All right, so it says, why do you think the 45, 45, 90 and 30, 60, 90 are called special right triangles? Remember, they're called special because you only have to know one side of that triangle and you can find the other two. So it makes it a little bit easier than Pythagorean theorem where you have to know two sides in order to find the missing one. So in your homework tonight, really pay attention to whether you have a 45, 45, 90 or a 30, 60, 90. Think about, are you going from shorter to longer or longer to shorter, so you'll know if you're multiplying or dividing, and then make sure you know your relationships. Are you doubling? Are you multiplying by the square root of 2? Are you multiplying by the square root of 3? You need to know these relationships, so the more you practice them, the better you'll get at them. All right, and don't forget, answers should be in simplest radical form.